All right, so when graphing an ellipse, just like with graphing a circle, I guess the very first thing is identifying that it is an ellipse. And you'll notice a lot of similarities with circles. You've got a plus sign, you've got x squared, and you've got y squared in here. The big thing is with an ellipse is that you've got these fractions. It's got to equal 1. And if you had a circle, so circles might look like this. You could try and write this in the same format as an ellipse. So if you divided this by 4, you'd get x minus 2 squared over 4 plus y plus 2 squared over 4 equals 1. So now this is a circle, but it looks, the format of writing is a lot more similar to an ellipse. The thing that you'll notice if you try to write a circle in the format of an ellipse, you'll notice that with a circle, the numbers in the denominator are the same, as opposed to here, they're different. Now, if it is a circle and you use the process that we're going to learn to graphing ellipses, it'll actually work to graph a circle as well. Okay, so there's a lot of similarities with an ellipse and a circle, and actually, again, if I go back to that thing one more time, if I were to make those numbers the same, you'll see it actually is a circle. And so a circle is merely, you could say that a circle is an ellipse where the focal points are at the center and your A and your B are the same number. So you'll see it actually works out that way. Okay. But again, so the formulas look very similar. The big thing is that it's got to be equal to 1, and you have the numbers underneath. Okay, so first thing, just like we would do with a circle though, is the first thing we want to find is the center. So start with finding the center. And again, you find the center in the same way you find the center of a circle. So we look here. The big thing to remember is that the coordinates are opposite of what you have in the inside of the parentheses. So here we have a 2 because it's it's x minus 2, and this is y minus negative 2, so the y coordinate is negative 2. Okay, again, remember, it ends up being opposite signs of what's actually inside the parentheses for your center. So I'm going to go ahead and put my dot at 2, negative 2, right there. All right, now if it was a circle, the next step would be to find the radius and then go that same distance in each direction. And we're going to do a similar thing, but the main difference between an ellipse and a circle is that it's not the same distance in every direction. Okay, so we're going to have to go a different amount. You can figure out how much you go to the left and to the right by looking at the number underneath the x. Okay, that number is your a squared. Now, and in this case, it's a because it's the bigger one. Again, a is always the bigger one, and that's merely because that's what needs to happen to make our focal point equation work. That's the only reason why a is stipulated as being the bigger one. So the number underneath the x's is 16, which is 4 squared. So since that's under the x's and x's is horizontal, you're going to go 4 to the left and 4 to the right. All right, now do the same thing with the number underneath the y's. So if you look underneath the y's, you've got a 9, which is 3 squared. So that means y, remember up and down, you're going to go up 3 and down 3. Then you just draw your oval. Okay, this is an ellipse, it's not a circle, so it's not going to be the exact same, but we have to draw with rounded sides just like we do with a circle. All right, and that is your ellipse. Okay, you'll notice that the bigger of the two denominators was underneath the x's, and you'll notice that the longer side, or the longer axis, referred to as your major axis, is horizontal. Okay, so now the only thing left to do is label the vertices and the foci. Okay, foci is just plural of focal points or focus. So if we say focus, that's the same thing as saying a focal point. Foci is saying multiple focal points. So foci is just the plural of focus, and you could also call those the focal points. Okay. So first of all, the vertices. The vertices are the points on the major axes. An ellipse only ever has two vertices. So when we drew the ellipse, we drew 4 points. But the vertices are just the ones on the major axes. So this is a vertice, and this is a vertice. And if we label those, it would be 1, 2, 3, 4, 5, 6, comma, -2. And over here, it would be -2, -2. And one thing I just want to kind of point out with the vertices is that if you look at those and compare them to your center, so in this case the horizontal axis, or the major axis was horizontal. If you compare those vertices to your center, you'll notice that the x is 4 less and 4 more. And 4 happened to be your A. So your A was 4, and that was under the x, so your major axis was horizontal. So your x was of the vertex was 4 more than the center and 4 less than the center. Okay, not a huge deal on the graphing, but that's going to come in handy to recognize when we get to the second part of this lesson. So just, it's nice to catch those things and notice those things now in this first part. All right. The other thing we have to do is find the foci, okay? And that we actually have to do some calculations for, okay? So now I'm going to go back for just a moment to the original slide. The foci are based off of your C. So here you can see where you find the foci, and I'll talk about these two formulas once we actually draw them in our graph. But the important thing is in order to find your foci, you need to find your C. And to find C, it's the C squared is equal to A squared minus B squared. It's not Pythagorean theorem, so don't get it confused with that. It does have a lot of similarities to it, but it is a different thing. So what we need to do is we need to take our A squared, so to find our C squared, our A squared is the bigger number on bottom, so 16, because again, A is the 4, so I should write this as A squared, so the A is 4, but we need to take A squared, subtract from it B squared, which is 9, so your C squared is equal to 7, which makes your C equal to the square root of 7. And then you got plus or minus. So now to graph your focal points, what you do is you go from your center and you're going to count square root of 7 on the major axis. So again, since this one, the major axis is horizontal, I'm going to go from the center to the left and to the right. Square root of 7. And square root of 7 is about 2.5. So I'm going to go 1, 2, and a little, about half over. That's my first focal point. So I'm going to label that focal point. Now, to actually write that, I don't want to write, because this is about 4.5-ish, but not quite. So I want to write my focal point as the precise focal point. And the way that I found that is I went from the center. So I'm going to start with the center. But I added square root of 7 to the x value because I went square root of 7 to the left. So you can write that like that. And because I only went to the left, I didn't go up or down any, you'll notice that the y of my focal point and the y of my center is the same. Okay, now I'm going to do the same thing from the center moving to the left. So 2 and about a half. I'm going to label that focal point. This time, again, I started at the center, but I went to the left, which is subtracting, and since it's left, it's subtracting from the x, square root of 7. I didn't go up or down any, so my y does not change, and that's the other focal point. Okay, so now I'm going to go back a second again, and now that we've done that, you can kind of see where this formula comes from. Right here, so the first one we looked at, our example, the major axis was horizontal. So the focal points, we use that h and k, but I added c to the h and I subtracted c from the h. And again, that was your x coordinate. All right, so now let's look at a second example. All right, first thing we do is we find the center. So our center is, we look for the number with the x, and we have to switch the sign, so it's going to be positive 1. And then the number with the y, now because there is no number here, it's 0. So I start with the point 1 comma 0. And then I look, under the x is 4, which is 2 squared. So that's under the x, so that's left and right. So I'm going to go 2 to the left, 2 to the right. Then I look under the y, which is 16. 16 is 4 squared. So from my center, and again it was under the y, so that's up and down. So I'm going to go up 4 and down 4. This time, you'll notice that the bigger number is under the y value. So the long axis, the major axis, is vertical, which means that this time my focal points are these top and bottom, because your focal points are always, or sorry, my mistake, these are your vertices. Your vertices are always on the major axis. They're the points on the ellipse that are on the major axis. So this vertex is 1, comma 4. This vertex is 1, comma negative 4, right? Lastly, we need to find our focal points. So we find that c squared. We take the a squared, which is the bigger of the two denominators, 16, minus the b squared, which is the smaller of the two. So our c squared is equal to 12, which makes our c the square root of 12. And so this time, because our major axis is vertical, it's a tall ellipse, not a wide ellipse. When I count c, which is about 3.6-ish, 3.5, 3.6-ish, that I'm estimating in my head, not using a calculator, so we don't have to be super precise on that. But all right, so from the center, because my ellipse is vertical, the major axis is vertical, this time I'm going to go from the center up 3.6-ish and down 3.6-ish. Now to label this vertex, or to label this focal point, this time, again, both times I went from the center, but this time I didn't change my x value at all. The x value is still the same as the x value of my center. The y value is what changed, and in this case it was 0. Then I added square root of 12 to it. So that's 0 plus square root of 12, which you can just write that as the square root of 12. But I just want you to see where I got it from. And then here I was at 0, and then I went down, which is minus square root of 12.